Hi guys, welcome to the interview series episode 1. Today we have Radha with us who would answer all our interview questions on the topic evaluation metrics on a classification problem. So let's get started. Hi Radha,
Hi Deepthi, what questions you have for me today?
a lot of questions. So let us quickly start. And the first question, what is accuracy?
Accuracy is the metric that measures how often a model's predictions are correct. So that can be defined as the ratio between the total number of correct predictions by the number of instances in total.
Exactly. So what is confusion matrix?
Confusion matrix is an n by n cross n matrix that summarizes the performance of a model. It shows values like true positives, false positives, true negatives, and false negatives.
Great. What is precision?
Precision is a metric that measures the accuracy of the positive predictions made by the model. It essentially answers the questions that out of all the positives predicted by the model, how many are actually positive? That can be defined as the ratio between true positives and predicted positives, that is, true positives and false positives.
What is recall?
Recall is a metric that measures the ability of the model to find all the relevant instances in the dataset. It essentially answers this question. Out of all the positives, how many of the predictions were predicted positive? This can be defined as the ratio between true positives and the actual positives, that is, true positives and false negatives.
Yes. So what is F1 score?
F1 score is essentially the harmonic mean of precision and recall.
Why do you think we use harmonic mean? Why can't we use arithmetic mean or geometric mean?
So, when we let us consider this with an example, like when the precision is 10 and recall is 90. So, we have this inequality, right? AM greater than GM greater than HM. So, if we'll consider arithmetic mean and geometric mean, the value tends to be way higher than harmonic mean. So harmonic mean gives weight to the lower precision values also. So that's the reason we prefer harmonic
Mm.
mean,
So basically, the harmonic mean weighs towards the lower value. So
lower
that's the reason.
values.
Okay, great. Then what is a balanced and an imbalanced data set?
So an imbalanced data set refers to a data set with an unequal distribution of target values.
Okay, what unequal you mean? Can you quantify a number?
So I mean like if an 80-20 distribution of classes can be considered as an imbalanced data set. 60-40, 70-30 are reasonably balanced, I feel. But a data set with 80% of positive values or 20% negative or vice versa can be considered as an imbalanced data set.
Great. So let me give you an scenario and let me know what is the evaluation metrics that you need to use. So
Okay.
you know spam detection, right? In the
Yeah.
emails that we get, so we have a separate spam folder. So there we do not want to classify a important email as a spam. It's
Mm-hmm.
okay, we let go a few spams, but we do not want to classify the important mail as a spam. So in this scenario, what is the evaluation metric you think you should use?
Okay. So we don't want to miss out an important mail as a spam. So in this case, false positives we should reduce, right? So precision is used in these cases where false positives are critical.
Mm.
So since we have to give importance to recall as well, we'll use F beta score in which precision is given more importance than recall. For example, if we'll use F, we want precision to be 2 times more important than recall, then we'll use F.5 score.
So beta has to be less than 1 is what you're saying.
Yes.
Okay. So what is F beta score?
F beta is the weighted F1 score where recall is beta times more important than precision. It can be defined as 1 plus beta square times precision into recall by beta square times precision plus recall.
Okay, so that's the formula you're saying. Okay.
Yeah.
Great. So I'll give you another scenario where, okay, you just have to mention which evaluation metric that you need to use. So the other one is, it's a, let's say I'm doing an interview. I'm just conducting an interview. This is a screening process, the initial process. So there, I don't want to lose out of any of the right person, but it's okay if I pick few wrong persons as well, because since it's an initial screening, I don't want to miss out on any of the right person. I'm okay to get few wrong persons to be screened. So which evaluation metric do you think we should use?
So here we don't want to miss out any talented person. So false negatives are critical in this case.
Hmm.
So in this case, recall is more critical than precision. So we'll have to give a more weightage to recall metric than precision. So it's better to use F beta score with beta value greater than 1, in which recall has more weightage than precision.
Okay. Okay. Got it. So next, what is AUC?
AUC stands for area under the curve and ROC stands for receiver operating curve. It is a crucial metric for evaluating the performance of a binary classification model. It quantifies the model's ability to distinguish between the two classes, positive and negative. It is a graph between true positive rate, that is recall, and the false positive rate.
Okay. What is false positive rate?
False positive rate can be defined as the number of the ratio between false positives and the total true negative sum of true negatives plus false positives, the total negatives.
Okay. The total actual negatives, right?
Yes, the total actual negatives.
Okay. So, what is the like difference between AUC metric and accuracy? Which metric
So
do you use?
yes, AUC ROC metric is independent of thresholds. I mean, like, so AUC ROC considers all the thresholds and calculates the true positive rate and false positive rate for each threshold and plots it into a graph. The area under the curve gives us the performance of the model, but accuracy gives only an evaluation metric for a given threshold. If you change the threshold, the evaluation metrics like true positives and false positives change.
Correct, correct. Okay. So how do you draw this graph? Can you explain in detail
Yes.
the AUC graph? Oh, sorry, ROC
Yes.
graph.
Uh, the ROC graph is as I mentioned before, it is the graph between true positive rate and false positive rate. First, you'll assume a threshold for classification and calculate the true positives, false positives, true negatives, and false negatives. And you'll get coordinates for true positive rate and false positive rate. You'll plot it, and then similarly, you'll change thresholds. You'll choose different classification thresholds and get different values of true positive rates and false positive rates. When you'll plot all this on a single graph, you'll get a curve, and that's how ROC is constructed.
So how do you interpret the AUC values?
Okay, so first we'll calculate the area under the curve, and if the area under the curve e- is equal to zero point 0.5, then the model is just like is making random guesses. It doesn't observe any patterns. If it is greater than 0.5 and if it's closer to 1, the model is performing really well on the data. If it's less than 0.5, the model that we built is worse than a random prediction.
Fine, correct. So what is the PR curve?
PR curve is, it's the precision recall curve. It's the graph between precision and recall. So this is a metric used to evaluate performance of binary classification models, especially when we are dealing with imbalanced data sets. This metric distinguishes how the model performs between positive and negative classes.
Okay. So what is okay? When do you use PR curve and when do you use ROC curve? How do we
So
identify?
ROC curve is relatively when the data is relatively balanced. When then we'll use ROC curve. But if the data set is imbalanced, then we'll choose precision recall curve instead of ROC AUC curve.
Okay. So what is k-fold cross validation?
K-fold cross-validation is a technique that is used to evaluate the performance of a machine model by dividing the dataset into k subsets, which are k folds. One fold is used as a validation dataset, while the remaining k minus 1 folds are used to train the data. This process is repeated k times with each fold serving as the validation set once. The results from each iteration are then averaged to provide a more robust estimate of the model's performance.
Okay. Okay. Yeah, I think this is the end of various evaluation metrics that we have for a classification problem. So, guys, try keeping your statements very clear as what we have mentioned today in the interview so that for the interviewer it will be clear what you are speaking exactly. So, guys, thank you. Please do practice and all the best for your interviews. See you in the
All the
next
best.
video.
Happy learning.
Happy learning.
Okay. Stop.
Actually,